Hi, my name is Trey Herr, and I'm the person talking to you from the tiny box in the corner of your screen. I'm also director of the Cyber Statecraft Initiative at the Atlantic Council. And while it would have been fun to do this in person, it's probably best that USENIX has made this a virtual event, so let's make the best of it. I'm going to talk with you today about breaking trust, a project the team here at the council and I have been working on for more than a year to profile attacks and disclosures in the software supply chain. Why the software supply chain? Well, even though supply chains have been in the news a lot lately, we don't hear as much about software as we do hardware, which is kind of concerning because first, software is everywhere. The sheer scale of vulnerability in the software supply chain is tremendous, and it grows every time we add a new feature to an already overbuilt code base or update a product on our machine. There's also in the US and many other countries, a lot of commercial off-the-shelf software underpinning major defense systems. This great quote from David Goldfein, the former chief of staff of the US Air Force, saying, "When I see the F-35, I don't see a fighter, I see a computer that happens to fly." So it speaks to the overall aggregate attack surface when we talk about software supply chains. The second reason to talk about software is we don't build most of the software that we use. Filippo Valsorda's talk at Enigma just last year called this out really well. Vendors and developers look to third-party code for increasingly critical functions, from the firmware on a mobile phone to container managers in a large cloud deployment to web-scale cryptographic libraries and more. Third, software and hardware aren't the same. Yet many of our mental models and no small part of our regulatory architecture for supply chains, especially in the United States, are built on assumptions about hardware. Software poses different risks and different opportunities. One example is how we establish and maintain trust in software. There are things we can do with code that we can't do with physical devices. So today I'm going to talk through what we've observed in attacks on the software supply chain over the last 10 years, run through some of our methods and the definitions that we use, talk through a summary of our data set and its key takeaways, identify a couple of major trends, and talk through this little recent issue with SolarWinds and the Sunburst malware that you've probably been reading about. Finally, I'll close with recommendations, and hopefully we'll have time for questions. Before I do anything else, a big thank you to the others from the Cyber Statecraft team here at the council who made this project happen: William Loomis, Stuart Scott, June Lee, and Emma Schroeder. Without them, I wouldn't be here and there wouldn't be much for us to talk about. Let's get into it. We collected between 2010 and 2020, 139 different attacks and vulnerabilities in the software supply chain. We started our collection in October 19 and ran through to July 2020 when we published our first report and the initial version of the data set at 115 events. We've since brought that data set fully up to date to the end of 2020 for 139 total events. What is a software supply chain attack? The key is attackers compromising code upstream of their target and manipulating it to compromise some downstream victim. This could be adding malware to an existing code base, altering that code to include malicious functionality, or even just compromising key parts of the deployment and development process, like stealing a code signing certificate. A disclosure, for our purposes, is a software flaw that would have enabled the above: hard-coded passwords in a deployment server, backdoors written to the firmware for a mobile phone, anything like that. So a software supply chain attack is realized. A software supply chain vulnerability is one that could have been. Why talk about both? There's a potential for attacks and vulnerabilities to show trends that are really important. What's most interesting to us about the last 10 years of these attacks and disclosures is less what they're doing and more where they are, the concentration of different types of code, different distribution vectors, how attackers get in. The other piece is we want to profile some of the dogs that don't bark as much as the ones that do. It's good that we're finding some of these as vulnerabilities and disclosing them. It's bad that they're still cropping up. We looked at public data, only publicly reported information for the period between 2010 and 2020. All of these incidents are based on blogs, media write-ups, articles, journal and conference reports, so they don't include private disclosures of attacks which never made it into the public domain. Because of that, even the trends that we identify probably undercount the frequency attacks on certain high-value targets, and they're biased away from regions that don't receive as much coverage from the vendors or the journalism space for the cybersecurity industry in the global South. This means that the data that I'm talking through today represents a lower bound on the population of attacks, which undercounts incidents that have never been made public. The data set presented here today is the full 139 events and is available today on our website. It's also going to be part of a follow-on project looking at SolarWinds and comparing it in detail to 7 other large-scale software supply chain attacks over the last decade. So let's get into the meat and potatoes of what we're actually looking at. 103 attacks and 36 disclosures stretching from 2010 to 2020. Everybody can argue about how you build software. We use this waterfall model as a simplified and generalized way to show the distribution of attacks and vulnerabilities over these 10 years. Our goal was something that was simple and was replicatable, really to paint just where software supply chain attacks and vulnerabilities land in the supply chain. And as you can see, it's spread throughout. One of the things that we get into later in the piece is focusing on hijacked updates, which is featured pretty prominently in the SolarWinds campaign. But throughout these different attacks through open source and proprietary code, through libraries, and just by abusing update processes, you can see there's a variety of different pathways into the software supply chain, and attacks have spread out across them. What does it tell us? First, that what we compile and the dependencies that we use matter a great deal. There's a lot of multi-stage attacks, first into an open source library, then to a piece of software, then to victims and users of that software. Second is that there's not going to be one silver bullet mitigation. And so we have to think about the whole of this life cycle, the whole of this supply chain. The third is that updates are a problem. They're an opportunity for developers and security engineers to push fixes, but they also require a great deal of trust by the customer. It's why we called this project Breaking Trust. We'll just call this part foreshadowing. A couple of key takeaways as we look at the data set. First is that software supply chain attacks have been popular, and they're going to continue to rise in prominence over time. We wrote those words back in June and July of 2020, and I think we've only seen them come true, unfortunately. Second is that software supply chain attacks that utilize this vector are impactful. It provides great bang for your buck if you're an attacker and want to spend small dollars to compromise one target to then hit many, many more users of that target. Third, these attacks are used to great effect by states. We profile 30 different attacks in the database that have some state nexus that have been attributed to state organizations by other individuals, other research groups. It's a significant trend out of 139, not just in terms of total numbers, but also in the scale of the impact that these attacks have, impacting hundreds of thousands, sometimes millions of potential users. The chart on the right shows the trend in attacks and disclosures by year. Orange are software disclosures, blue are the actual software supply chain attacks. The big piece that we see here is less, because this is an imperfect sample of the space, a trend in overall supply chain attacks. It's more reporting and visibility to them, but the trend is not good, right? We're seeing more of these attacks over time, and they're having pretty significant consequences. There's a great incident from 2016 and 2017 where attackers compromised the firmware that came pre-installed on Android phones in order to build a backdoor into those users' digital environment, the Triada attacks. This kind of effort has happened multiple different times with different vendors, although Android's been a pretty prominent target given the diversity of that ecosystem. Open source is also a focus. There was an incident in 2018 with WebMint, this Unix system configuration tool that was released with a vulnerability that allowed for remote code exec that was introduced by an attacker and was downloaded more than 900,000 times before it was caught and that fix mitigated. So there's a significant attack surface here, and it's being exploited on a pretty regular basis. In terms of trends, go through 5 pretty quickly. First, we found at least 30 different state attacks, including attribution from other parties to states like Russia and China, as well as the United States, North Korea, Iran, and some smaller cases from India, Egypt, and Vietnam. Most of this attribution is sourced from private firms and the rest from government's public statements, so we make no claims of attribution ourselves and did work to include all events for which there was public information available. The second trend is that these attacks undermine public key cryptography and the certificates used to ensure the integrity of code. The attacks on code signing, even if it doesn't actually abuse the update process, allows attackers access into target supply chains with pretty great frequency. Third, we saw attackers targeting widely used open source projects, popular open source code across the web, and targeting a number of different repositories. Fourth, 25% of these incidents targeted app stores like the Google Play Store and Apple's App Store, as well as other third-party app hubs to spread malware to mobile devices and to compromise developer tools. It's a great example in the Xcode Ghost malware in 2018 that compromised a software development kit and was able to impact every single piece of software developed with that SDK downstream, impacting hundreds of thousands of users. We're going to talk about examples from a couple of these, but recent events demand a bit more focus on our last trend, which is that 26% of these incidents targeted software updates. So let me zoom into the figure here on the right. This shows the distribution vector of these software supply chain attacks by year. So this is, how did a software supply chain attack actually get delivered to the target, and then mapping that over the course of the year. That orange bar in the middle that stays present in almost every one of these is attacks on software updates. 26% of our incidents targeted updates, which counted for 36 total incidents stretching back to 2010. Of those 36, 15 targeted build infrastructure or development infrastructure versus updates, which is to say they altered source code or compromised an installer or as opposed to compromising a deployment server. So in the case of SolarWinds, I'm actually impacting source code as it's being built, developed by the team, versus an instance where I've compromised an update server and I'm simply attaching my malicious code to an already signed or about to be signed package. Nearly a third of all state attacks that we profiled targeted software updates. So it's a major part of the attack surface, and it's something we want to talk a little bit more about because of the prominence of this latest attack on SolarWinds. So looking just at this overall population of 139 events, we zoom into the 36 focused on hijacked updates. Let's talk about SolarWinds. SolarWinds is an Austin-based company that builds a network management software called Orion. Orion was compromised at least as early as September 2019, when attackers were able to gain access to the company's build infrastructure and included a malicious library wrapped into the source code for the overall program. That malicious piece of functionality was carried through SolarWinds' development pipeline and into its deployment infrastructure, where it was made available to users all over the world. That probably began as early as February 20, where that malicious version of Orion was distributed to users. And it creates an interesting problem for the policy community because as the attackers, in this case, focusing just on SolarWinds for the moment, were able to gain access to one company, they could impact through that Orion software more than 18,000 customers around the world. This includes names like the likes of Microsoft, FireEye, NVIDIA, and Intel, as well as companies across Canada, Mexico, Israel, the UK, the United Arab Emirates, and more. So again, that cost to benefit ratio, one attack on one company yields the ability to gain access to lots of other firms. We see customers between February and June of 2020 accessing that update server, downloading those compromised versions of Orion, and the Sunburst malware is off to the races. Now, I'm not going to talk too much about what happens once Sunburst lands on these in these organizations. There's some really intriguing techniques used to drive lateral movement, including the so-called golden SAML, golden security assertion markup language attack, and a lot of emphasis on attacking Microsoft Office 365 and Azure Active Directory, although the company has come back to say that there's no technical vulnerabilities in that infrastructure. It was certainly that identity and access management technology was certainly a major factor in the attack. So looking at SolarWinds, although they're only one vector into these attacks on email infrastructure and Office 365, we see a really classic case of a patient supply chain attack, software supply chain attack, focused on build infrastructure. So looking through all of this question of software supply chain attacks over time, what is it that we as a community have an opportunity to do? How do we address a problem like SolarWinds? The US government's going to have to get smarter about prioritizing risk and establishing a risk register of products with the largest potential blast radius across both .gov and .mil networks. That's going to mean improving funding available to all agencies to modernize their IT infrastructure to support better security practices. But there's more to this than just SolarWinds. As we've shown, 138 incidents more in the last decade, in fact. If you walk away from this talk with one message, let it be this: the security of software supply chains are lacking, and the problem is neither new nor likely to go quickly away. Baseline best practices are still too hard to get right, and we have to find a way to internalize that performance, security performance and maturity tells us more than provenance. How well does a vendor perform? How well does the security of their product perform over time versus where is that product from? Still, to this day, too many of our controls and regulations focus on development and leave deployment and lifecycle maintenance as an afterthought. Too many of those same regulations and risk management schemes are implemented in PDFs and in spreadsheets instead of digital tool change. And too few of these risk management schemes recognize our incredible dependence on software that we don't buy, build, or directly control. So to try and address this, Here is a snapshot of 3 clusters of recommendations we develop in more detail in the report associated with this talk. First, we have to work to make software supply chain attacks less frequent by making it easier to deploy secure software, thereby improving our baseline. We make a couple of recommendations in this bucket, but I want to call out 2. The first is for the US government, along with private sector partners, to develop a lifecycle security overlay from NIST's 800-53 controls to take those controls that are most applicable to lifecycle security for a software vendor and publish them as a separate overlay. Make it easier to implement those controls and easier for firms to pick those up and drop them into their development process. The second is we're calling for industry, especially the 3 major cloud service providers in the US, Microsoft, Google, and Amazon, to take that lifecycle overlay and offer public reference implementations of their products so that developers who are new to the space or are working and don't have time to read through a PDF to figure out how to interpret it and apply it can take a reference implementation from one of those vendors and drop it into their workflow. Second, while SolarWinds and some of the associated attacks around it were focused on proprietary code, we can't forget about open source. Open source attacks make up a decent chunk of this data set, both in attacks and vulnerabilities. And we have to do more to improve the security of code that everybody uses in products, both proprietary and open source. So we have 2 recommendations here. The first is to provide funding, the US government, on the order of 20 to 25 million for baseline security improvements in open source software. This would be a new government program administered by an existing agency that provided funding on 2 tracks. The first was discretionary on the part of the government to any open source projects it felt were particularly consequential or lacking in significant security maturity. The second would be an open application for grant funding, sort of along the lines of the Open Technology Foundation, where projects and programs could come and apply for grants from this program to improve their own security, gain access to security tools, pay volunteers, and overall manage more effectively the lifecycle security of their project. The second recommendation here is to establish a transatlantic infrastructure initiative. The US is not going to address this problem alone, and there's very little software out there in the world that's not been globalized in some fashion. There's no reason that the United States shouldn't be working with allies in Europe in particular, but also Asia, to address the security of these products and these open source packages. This kind of funding model and these sorts of changes to standards should absolutely be happening across multiple jurisdictions, not just in the United States. Third, we argue that we should be working to better limit the consequences of the most severe supply chain attacks. And in that is to focus on better countering systemic threats. The 2 recommendations I'd call out here, first is for the US to add new international partners to investigate and prevent catastrophic software supply chain attacks. That's entities like DHS, CISA, and the NSA and DOJ working with good partners in the UK and France, Germany, and the Netherlands to make consequences more severe and investigations more rapid and effective for major events like the SolarWinds and Sunburst attacks. And last, the recommendation here is for the US and allies to support strong cryptography and standards and tools. This is one of those bugbears that keeps coming back around every few years, but a lot of the software supply chain security that we talk about is premised on strong cryptography. The signatures, the ability to transfer code between entities and at least assert its authenticity, a lot of that is premised on strong crypto. And so defending that is a core principle of any of this work. At the end of the day, we have to grapple with a world that software has created, right? The notion that software has eaten the world is sort of old hat, but at this point, we got to live with the results. Trust in software isn't built in isolation. It doesn't come from slickly branded 0 days, widespread government mandates, or from any auto magic industry initiative. It would be a mistake to equate software supply chain attacks to a new weapon system in an opponent's arsenal. They are a manifestation of opportunity, attacking secure targets by compromising weaknesses in connected neighbors and vendors and in those dependencies. For the technology industry, the insecurity of the software supply chain is a crisis in waiting. For the national security establishment, it's a crisis realized and a generation of technology acquisition under threat. Breaking trust takes time, and restoring it will require concentrated purpose and clarity of outcome at a time when both are in short supply. But the SolarWinds response has demonstrated the extraordinary technical and collaborative capability of the security community. We can drive new research and investment to help secure the load-bearing bugs, implement revised policies and straightforward tools to make secure development easier, and expand community-led efforts to bring supply chain security further out of the darkness of the Byzantine and proprietary and into the harsh light of day. At the outset of a new year, I remain hopeful.